So that's that. The next part we have to talk about is what we have to address today: core architecture components. So I encourage you to always go to the website. If you go to our website, you can click on events. From the events, the most recent event is session 4 today. But since we did not cover session 3, I'm going to use about 30 minutes to see if we can go through session 3. So session 3 is a little bit lower. I'm going to click on read more. That should take me to a dedicated page for session 3. On this page, you can always join the class by clicking on the blue button, and it points out the objectives, the things that we need to achieve today. The audience, obviously, you need to have some information about last week. What you need to do is click on curriculum. If you click on curriculum, you see the link to the lecture. So clicking on that link takes you to the lecture. From there, I'm going to expand it so that you can see the slide that we're using. So before we get started, what questions do you have? That was a very lengthy recap of week 1. Everybody is good with week 1 so far?
Yeah.
Awesome. All right, so let's go ahead. Today, what are we going to talk about? We're going to talk about Azure core architecture, okay? So the basic infrastructural components of Microsoft Azure. We'll learn about the physical, the physical things that make up the infrastructure, as well as how those resources are managed. A few things that we need to achieve by the end of the day. We need to be able to describe what regions, region pairs, and sovereign regions are. Within these regions, we have availability zones. We'll describe those. And within availability zones, we have data centers. That's the relationship between them. All of those 3 bullet points cover the physical architecture or physical infrastructure. The next, we're going to talk about the management infrastructure, which has to do with resources and the resource groups, which make up subscriptions, and also talk about management groups that go across subscriptions. We'll discuss the hierarchy, and that should be it. It's not a big deal, right? So that's what we're missing. But please interrupt me and let me know if you have any questions. So this is a short video. Let me talk through it because you probably cannot hear. What is Azure? Azure is Microsoft Cloud Computing. So it has a bunch of services that are built on many things. It provides us infrastructure, platform, and software as a service. Services that they have include virtual machines that you can build. You can also have computing services, databases. You can even have Internet of Things, machine learning, and so on. But you are not being charged for all of these. You are only charged for what you use and also for the time that you use it. So if you want something that is dedicated to you, you can create your virtual machine, or you can even have your virtual machine that you have created, you upload it on there, or you can use a template that have been set up for you. If you just want to store your stuff or you want to back up your information, you can back up your information. Or if you want to create a website, you can host your website on Azure so that you can use any development framework, whether it's Java, PHP, and so on. Finally, you can launch your server using functions which are tied to servers. We'll talk about this as well, but they are not necessarily absence of servers. You also have containers and Kubernetes that manages containers. So you can deploy your applications in containers, or you can have all different types of databases also on Azure. If you prefer, you can use Cosmos DB, which uses all those different APIs to work with all the databases. So machine learning services, Internet of Things, AI, they are all in there to help you build, deploy, or learn data. And at the end of the day, the physical part, you have these data centers all over the world, So it makes it better for you in performance because it's hosted all over the world. Anybody can get to it easily. For you to manage it, you can use Azure Portal, or you can use the back end, which we'll talk about. So all these services are available for you on top of their infrastructure. And then they handle your security. They make sure it's elastic and capable to expand, and it's also scalable, right? So at the end of the day, that's what Azure offers for you, and that's what you can do with it. Does that make sense? So all of this is what we're going to cover today, and what we have talked about, some of it. And at the end of the day, you should be able to, I'll send you a copy of this. You should also have it on our website and also on Google Classroom to be able to listen to this over and over. You understand exactly what is going on in there. Without talking much about that anymore, let's break down all of that piece by piece so that everybody can understand, because that's a lot, right? Awesome. Let's break it down. First up, core architecture is broken into two parts. The physical one, as you can see here, these are all servers that are being stacked in a rack. All those servers are connected. You can see the cables that are connecting them, okay? And all of them, maybe you have one monitor out there. A server, again, is just like our computer at home, but it does not necessarily have a screen because it's just connecting other computers. It's serving them with information. But it's not just like our computer because it has a lot more capacity, a lot more compute power, and a lot more bigger hard drive compared to our tiny ones that we have. So all of this can be servicing just one area. I mean, there are stacks and stacks on the rack. All the entire rack makes a whole row, and all of those, there are multiple of those that make up a data center. So that's what makes up the physical part of it. But now you have to be able to manage it. You're the manager. You decide on how you want to manage your server, which is located on the cloud. To be able to do that, the smallest building block is a resource. So let's start with physical infrastructure, which starts with a data center. So what's a data center? A data center is just a bunch of servers together that perform a particular thing. As you can see here, you have a data center at this location, which is connected using fiber optic paths, multiple diverse ones, to another data center. So you could have just one data center or multiple data centers in each availability zone. So we're going to talk about the data centers. An availability zone is one or more data centers that are in close proximity. So when they're in close proximity, they are connected in such a way that there's no latency. What is latency? Latency is delay. So for instance, if you speak and then it takes a minute for someone to hear, that's due to latency, that's due to delay. But we don't have latency when data is being transferred within an availability zone, because the data centers are so close that they are very low latency. Now, an Azure region could have 3 or more availability zones within it. So a region, for instance, let's say Brazil South. Brazil South could be a region. Within this region, it has multiple availability zones, right? If you look at South Africa North would be another region. That region has multiple availability zones within them. Within each availability zone, you have data centers in there. So that's what you call a region.
Excuse me. Yeah, sorry. I just want like these availability zones, they interconnect with each other. Is it by using physical cables like optic fibers, or is just some kind of um, just an open space interface communication? Like maybe you can have a communication tower that intercommunicates with another one.
Very good.
Kind of
Very good question. Very good question. We're definitely going to get into it in the next couple slides. I think the next slide. But this is just painting a big picture of what makes up the physical infrastructure. So the physical infrastructure has these data centers, availability zones, regions, And the next thing I was going to talk about is region pairs. And finally, sovereign zones, which we are going to talk about in depth. So let me dive into that and see if I can answer your question by that. Okay. So here is the region and an availability zone, right? A region is a particular geographical area. Okay. You have one or more data centers in there, and they are always networked together with low latency network. What is low latency network? It's definitely fiber optic. So your question, as you can see on the fourth bullet point right here, the availability zones are connected with high-speed private fiber optic networks. Does that answer your question?
Yeah.
Awesome. So yes,
So despite the high speed, there's still like a chance of experiencing latency or not.
in this case, for a region, remember a region contains multiple availability zones. Within a region, there is very low latency. So there is no latency in this case. Does that make sense?
Okay.
Yes. So the goal here is, for instance, if you look at the previous slide, the goal here is if your customers are in West Africa, you probably want to deploy your application in South Africa because it's close. If your customers are in Central US, you probably want to deploy your server somewhere around here. There's no point in you deploying it in Australia when your customers are in Central US. If your customers are in Australia, you have options that are close to it that will make sure that there's redundancy. If one region goes down, the other region is still up and going, and you have high speed and quick agility in getting your deployments and getting your resources running. Does that make sense?
Yeah, it makes sense. But
Awesome.
the only sad part is looking at these various regions. It shows that Africa, we are left behind. We just
If
South Africa.
if you were
South Africa.
Microsoft, will you go and
Yeah,
build a data center in Cameroon?
I know that's what I'm saying. That we're really lagging behind because look at Australia. Australia has about 4,
Yes,
and
because
Africa being
they know about
yeah,
the corruption and all these difficulties that they'll have. Eventually, things will change. Maybe East Africa is going to have one shortly, but I know that they are growing quite a lot. And I'll send you a few links that you can check out the number of servers that keep increasing and how they go. But going back to it, a region can have one or more data centers, right? Within a region, in this case, as you see on the right, you have 3 availability zones. What is very important for the availability zones is that they have independent power, they have independent cooling and independent networking. So that if availability zone 1 goes down, availability zone 2 is also still up and running and you have no problem. And the way it's set up, we'll talk about it when we talk about storage. You might decide to back up everything that's in zone 1 is copied over to zone 2. Everything that's in zone 3 is copied over to zone 1 so that there's redundancy. If any zone goes down, you have a backup on the other one. No matter what, your data cannot evaporate from space. So again, if it happens that the power goes out in zone 1, that's fine. Everything is either in zone 2 or zone 3 or zone 2. Your system will still be running perfectly fine. Your services are still running perfectly fine. In the meantime, they'll make sure it's up and running again. At some point in time, power is going to return. If it overheats, then they shut it down. The other system is running. So that heating or cooling, and if the network gets breached for one reason or another or gets affected, interrupted, the other networks are running, so your system is still good. So that's the way it's set up to make sure that within your region, you always have that availability. But the availability zone has a boundary and isolation boundary set up that ensures that it's not overlapping with the other ones. Okay. So at the end of the day, not every zone, or should I say, not every region has availability zones. Some regions don't have, but for every region that has an availability zone, they have at least 3 separate availability zones in there. Okay. So I'm not very sure which regions have availability zones right now, but it keeps changing too, depending on how new the region is and what resources they have in there. But that's it for the first part of the physical infrastructure. The next thing we needed to talk about was region pairs. So region pairs, again, this has to do with making sure that for one reason or another, if there's a catastrophe in one area, you have your backup available. So you can see a region in here. Let's say this is South Africa North and this is South Africa South. They can create a region pair within the same geography. In this case, South Africa is a geography. So within that geography, it's at least 300 miles away. That's to make sure that all your data is replicated and there's serious redundancy, or should I say serious reliability and redundancy. No matter what, your data has its security, you have disaster recovery. One thing happens in one area, it's not going to affect the other area. Does that make sense? So the key with region pairs is to make sure that it's at least 300 miles. In addition, you also have sovereign regions. There are these problem people out there that like fighting, right? So even though we all are part of the Azure public cloud, you also have the US government cloud because they want their own things private, the German cloud, which is also private, and China's own cloud, which is private. So those are all what we call sovereign zones. Okay, there are instances of Azure that are isolated from the main instance because the US Department of Defense does not want its data mixing up with Chinese data and German data and our own data. So it's all unique. Does that make sense? So that's about it. In a few minutes, we have been able to talk about what physical infrastructure is made up of. And I believe, Gilbert, you had a question earlier about something like this. I don't know. Does this answer your question from last week?
Not really,
Okay.
because the question I asked you, I was trying to know if there's any data protection law or regulation that helps to ensure that data are safe. Your data is saved.
Oh, I
Like a
see. I
law or
see.
regulation. Yeah. Something like that.
Yeah. So let me escape from this real quickly and go back to our notes. So what we are doing today is just the architecture, core architecture. Later on, when we get to the final week, we're going to talk about governance and compliance. That's definitely going to capture that, as well
Yes.
as
Yes.
when we talk about identity, access, and security. That's definitely going to cover that, so that I don't want to deviate from our goal of today. Once we get to that, we'll definitely answer that question. Does that help?
Yes.
Awesome. Awesome. All right. Do we have any questions before we move on to the management infrastructure? No questions. All right. So management infrastructure, everything that has to do with the physical part, we have done and over with it. Now, when we talk about management, what are these services? We keep saying that cloud computing is services that are provided over the internet. What kind of services can they give us? There are many services out there. Okay, as you can see, there's virtual desktop, there's web app services, there is also database services, and so on and so forth. Each of these services is known as a resource. That's a terminology that Azure uses. So you can create any of these resources. You can also group the resources to help you manage them. And then you have a subscription, just like with Netflix or Hulu, you have subscriptions in there and you pay for that subscription. Like your phone bill, you have a subscription for your phone bill. So for Azure services, when you create an account, you automatically have a subscription. You can create multiple subscriptions to track your bills. Think about a company. The company knows that, okay, I'm going to be having my database from the sales team. They'll create a subscription for the sales team and create their database. I'm going to have another database for marketing team, or I need an application for the IT team. Each one of those teams can have their subscriptions. and then you track their billing separately, and at the end of the day, you also have management groups. Those management groups can then have multiple subscriptions that it tracks, and you say, okay, this finance team is in charge of this management group and so on. So we'll talk about all of that and their hierarchy. But let's start with resources. What are resources? There are many, many resources in Microsoft Azure. I mean, I don't know, maybe 200 or 300. But once we start using it, you get to see they are broken down in multiple categories. There's obviously the general and the big three that we keep talking about: compute, network, and storage services. All of these could be things, for instance, like virtual machines, virtual networks, or databases. Anything that you create, or anything that you deploy, or anything that you provision on the cloud is a resource. So it's a basic building block of Azure. But now for ease of management, you want to group them together. One resource can only be in one group, but one group can have many resources in them. Okay. One plantain plants can have many bunches or many plantains on one bunch, but one plantain cannot be in two bunches at the same time. All right. So at the end of the day, if you want to say you apply something to a resource group, whatever you apply to that resource group gets applied to every one of the resources that are currently in the group and any other resource that you're going to add to that group after. Okay. So you can have security, just like Gilbert was asking earlier. I can decide and say, you have access to this group. If I give you access to this resource group, anything else that I add to this resource group, you will have access to it. Okay. So that's the breakdown for those two. Next up is a subscription. So think about your subscription. You might also have a team. Let's say an IT team. You decide and say you have a development team, a testing team, and a production team. You decide how much you want to budget on each one of those. So each one of them can have their subscription. The developers can go ahead and be working in the development subscription and tracking it. Those that are doing testing, quality engineers and quality analysts can be doing that in the testing subscription. And when your application is live, everything that's running on your live website or your live application, that's going on in your production subscription. So it depends on how you want to set up your account. Your account can have multiple subscriptions or just one. Okay. So subscription again is just your unit of management or billing or scaling. So logical, organized according to how you want, and it helps you facilitate that billing. But your management group can have multiple levels, right? If, for instance, you have multiple resources, or you have multiple teams, or you have multiple locations, you might want to be able to track Africa, Europe, Asia, and so on. It becomes difficult if you have just subscriptions. So in that case, subscriptions and resource groups is not going to be sufficient. Then you're able to have enterprise-grade management at a larger scale, and you can even nest them, just as you see in this case right here. So you have your root management group, which has human resources at one end. In human resources, you also have applications in there within the human resources. All of these are still management groups. The management groups, and then you also have a dev and a test subscription. Now, if you look at the IT management group, you can give them access to production, give them access to multiple regions. Each one of those regions has different subscriptions as well. And then finally, you might have marketing, and you want marketing just to be able to track those. So whatever you have within each management group is going to have access to what is in the child group or the grandchild group, and so on and so forth. Does that make sense? So it's a hierarchical level, just like whatever your grandparents have available is also available to the parents and the children and the grandchildren, and so on and so forth. Sounds good? Looks like we have no questions. So at the end of the day, how do you access all of that? To be able to interact with Azure, there are few things that I need to point out here, which we'll talk about again in detail. So let me talk about that shortly. So let me escape this. Again, you have your hardware and your software, right? So let's see, where is it? There you go. So let me go ahead and draw this real quick for us. Let's get a blue one. So normally you have hardware, right? Your hardware is able to interact with your software. Your hardware could be your keyboard, your mouse, screen, and so on. In order for your hardware to interact with your software, it needs something known as an interface. Okay. For instance, in your car, in order for you to drive your car, you need an interface. The interface is the steering wheel, your gearbox, and your brakes and pedals, all those things. You don't really know what happens when you step on your brakes. All you know is that the car stops. You don't know what happens when you step on the accelerator. All you know is that the car moves faster. That is an interface. The same way, we don't know what happens inside the computer when we type A, B, C. All we know is that it shows up on the computer. So there are two types of interfaces normally that you get in a computer. You have the command line interface, which is known as a CLI. Command line interface, what you usually see is black and white, but it looks like the back end. You also have the graphical user interface, GUI or GUI. Those are the two interfaces that help you interact between your hardware and your software. So again, in this case, we are looking at Azure. We can interact with Azure using command line interface or GUI. The GUI is usually what you can see that looks nice and beautiful, like the Azure portal. So let me clean this up and we can continue from here and I can explain what you see in this case. Does that make sense to everybody?
Yes.
Awesome. So in order for us to interact with Azure, we can use PowerShell commands in the command line interface, as you see on here, the blue background. PowerShell is usually the command line interface for Windows operating system. If you're using Linux operating system, you're going to be using Bash command line interface, which is short for Born Again Shell. I don't know if anybody here knows about palm nuts. Any man know Banga? Okay, everyone is on mute. When you have Banga, from Banga, something they call and say shell, just like egg. Egg has a shell. And from Banga, something they call and say kernel. Any man for you chop kernel? Exactly. It's the same thing with our, what do I call it? With Azure. If you look at Azure, let me go back to what we were talking about earlier. Nope, that's not what I want. Okay, so in here again, you have your hardware and your software. The software interacts with the hardware using what you know as the operating system. Okay. The operating system also has its own parts. So the operating system, if it's Windows computer, you have Windows operating system. If it's Linux, you have Linux operating system. If it's Mac, you have, well, it depends. If it's on a cell phone, it's iOS. If it's Android, it's Android operating system. So your operating system has that hardware in there that it interacts with. Inside, you have the kernel. So your kernel interacts directly with the hardware, but outside you have the shell, okay? Just like you have the shell of the egg and then the yolk, just like you have the shell of the kernel that you crack to get to the kernel inside. So all of this is the same concept that is being used here in programming when we look at where's my expander? When we look at
Wait,
born
I have a
again
quick question.
shell. Yes.
Yeah, yeah, please. You talked about operating system, the hardware and the software. So I thought that like the operating system as well as language, be it a programming language, whatever, constitute the software in a computer. That's how I used to think.
That is correct. That is correct. The two main things in the computer, if we have to look black and white, is hardware and software.
Yeah.
But between the hardware and the software, you have the operating system. So the
Okay. Okay.
operating system is what interacts your hardware and your software. You can buy all the keyboards you have, all the mouse, all the monitor. Nothing is going to happen until you take that hardware and connect it to a Windows computer or a Linux computer or a Mac computer.
Yeah. So the point I was trying to make is I thought that, as you rightly said, a computer constitutes the hardware, which of course is the physical, tangible object that you can see, feel, touch,
Yeah.
and then whereas the software, I thought the software now is constitute like the operating system, the programming language, whatever, yeah. So now when you said that the hardware communicates with the software through the operating system, now I started looking at like as if there are three objects there, which you have the hardware, you have the operating system, which acts as an interface to the software. I start looking at it from that perspective. So I don't know if I'm too uh, widening my scope of imagination or.
No, you're good. You're correct. You're correct when you say that, because when you look at it at the end of the day, the hardware is what we touch, feel, and see. Within that, there's a clear demarcation between hardware and software. But the software, remember, there are two types of software. There's application software, and then
Okay.
there's system software. The system software is where you have that operating system that
Okay.
connects with your hardware.
Okay.
And then every other app is short for application. Every other app that you see on whether it's a market or on your computer, whether it's Microsoft or if it's your web browser or if it's any say utility application, they are all application softwares and so on. Does that make
Okay.
sense?
Okay, makes sense.
Yes. So it's very good to remember those, because that's what helps you understand the bulk of everything else that comes in thereafter. Okay, so that's why I wanted to take time to explain this part to everybody to understand. So yes, again, the shell, that's where born again shell comes from before. There are different types of shells. You are going to hear K shell, C shell, bash is born again shell, depending on which type that you like to use. And then Azure actually has one stuff that is called Azure CLI or Azure Cloud or the CLI, which actually has a combination of these two. Then you can decide to choose, hey, I want to use Bash because I am comfortable using Linux computers. Or hey, I want to use PowerShell because I'm comfortable using Windows computers. That's if you want to be using backend, or if you want to write a script to do your things for you, or if you want to automate stuff using the script. What most people usually do, and what we are going to be using most of the time, is the Azure portal. The Azure portal now is the GUI, the graphical user interface, that you can go in there and see buttons and colors and text and so on that you can click on to be able to create resources and do whatever you need to do. Does that make sense? So the CLI could also be interactive, as you see. When I say interactive, it means you don't need to memorize all the commands. You can start typing and then it fills it up for you. It automatically tells you, okay, these are the options. Do you want to just tab and enter it? We'll look at that in April a lot more when you want to talk about administrating cloud, Azure, should I say, administrator associate. But yeah, that's about it for how you go about managing your software or managing your Azure on the cloud. All right. So with that, Just a recap again, you create an Azure account. When you create an Azure account, it gives you a subscription. Based on that subscription, it's always advisable to create a resource group. Within that resource group, you can start adding resources. If you give someone access, you can either I can decide that I'm going to give Egbe access to SQL. I can give him access directly to SQL, or I can give him access to the entire resource group. When you give him access to the entire resource group, then whatever you add to this resource group, he automatically has access. Whatever you add to this, just like here, if Gilbert has access to this group, that means he has access to every resource within that group. So if it's your first time using Azure, you can create an account for free. If you have a student login, you can create an account for free. But it also has Microsoft Learn Sandbox that helps us out quite a bit. All right. That said, a quick quote before we take our break for the day. Steve Jobs, I think everybody here knows Steve Jobs, the late chairman of Apple. He did say at one time in 1997, that was way before cloud computing. He said he does not need a hard disk in a computer if he can get a server faster. Okay, if he can get to the server faster, he doesn't really need a hard disk on a computer. So carrying around these computers that are not connected was very, very cumbersome, was very, very tedious for him in comparison. So those are all the things that started this idea of cloud computing. Have a server somewhere that you can connect everybody's stuff to, and we don't have to be carrying huge computers all over the place. All right. Question, Mr. Tibato. You're on mute. You have to unmute.
Oh, okay. Thank you. Yeah, I have a quick question with that optic fiber. How is it? How is that optic fiber being like interconnected with different the geographical zones?
Very, very good question. So his question is that in that connection, right? So you understand you're okay with the part that the optic fiber has connected these, but now how does it go from here to there? Okay, in that case, I think it has a satellite. They have their dedicated satellites that are able to connect those regions together. Obviously, they're not going to be able to run fiber optic cables, but within this region, these are connected by fiber optic cables. These are connected by fiber optic cables. But then you have one region that connects to the web on the another region. I know we have 1 minute before we get on our break, but let me show you quickly. If I go to, I've forgotten the name, Azure Cloud Geography, something. I forgot the link. Where is it? Global infrastructure, there it is. So if you click on that, it's going to show you how those are all connected. And I encourage everyone to go and explore. It even takes you into the data center. You can see what the data center looks like. You can see the security of the data center. You can see all those things that are tied in. Okay, so it helps you look at the global infrastructure, how it's connected. So for instance, you see the world map, and then you see how they are all tied in, and it's going to load up everything on there, including the satellites that are roaming around the Earth. Those satellites are what is helping each one of those connections to be made successfully. Does that help?
Vitus, I think I think there is like under sea, under water cables that basically interconnect like Europe and United States. I remember when this crisis just started in Ukraine, Russia was trying to explore a certain area around the Northern Ireland line like that, which the Europeans, they were scared that they're trying to map out an area that runs on a cable, underwater cables between, that's optic fibers between UK and United States. In case of something, then they can target it as some kind of they consider as a security threat. So, and also I heard of some in the US military base in is it in Guam or Hawaii? I think Guam.
Yeah, either one of those.
which they also said that Russia had a surveillance ship around that area, which was kind of scanning like undersea cable in case of, they're trying to look at an object that you can target your adversary and cause them severe impact. So I also think that they run physically underground, underwater.
Yes, they do run those underground high, what do I call them? Low latency networks. As you can see on the map,
Okay.
all these lines that are being drawn, those are all the cables. But
Okay.
in some cases you have to be able to get that satellite connection between one area to the other as well.
Okay.
Make sure that the users, you don't necessarily need to leave from South America to go through all these connections before getting to Africa. You can also connect through the satellite and directly hit Africa without going through all the different hubs. Does that make sense?
Yeah, it makes sense as well.
Yeah, but I encourage you to go to infrastructuremap.microsoft.com and explore it quite a bit. So it's 2 minutes after the hour. I would hate to keep you guys longer. I always have my way of doing things in that I want to make sure that we have a 10-minute break after we walk for 1 hour. So you can stand up, drink some water, use the bathroom, clear your head, make a few phone calls if you need to. And then we'll come back in the next hour. We should be able to clear out the rest of it. So we've made it all the way to the end here. After the quote, you just have a summary. In this case, the summary again, let me expand this. The summary, we have been able to describe regions, region pairs, and sovereign regions. We also described availability zones and data centers. We went ahead and dived into management, infrastructure, talked of resources, resource groups, subscriptions, management groups, and their hierarchy. So with that, assuming we don't have any questions, so we should be able to take a quick break. In 10 minutes, I'm going to set a timer. In 10 minutes, we'll come back and then we'll carry on with chapter 4, or should I say session number 4. Session number 4, which is going to talk about compute services. So we're done with the architecture. We should be good to go now with compute services. Sounds good?